in space. Hello and welcome to another episode of the podcast. I am your science communicator, Alex Giorfanos, and today in space, we're talking about the discovery of a small lake of water a few miles beneath the surface of the South Pole of Mars. The question we're asking is, why does this discovery of a source of water on Mars matter? It's not the first time NASA has said that they've found evidence of water on Mars. So then, why is this one different? Why is finding liquid water important in the first place? I'll do my best to answer these kinds of questions, or at the very least, get us thinking about it. So, let's do it. According to an article from CNN, the Italian Space Agency is reporting that they have found a subsurface liquid lake by radar from orbit with the instrument MARSIS, the first radar sounder to ever orbit another planet. The instrument, the Mars Advanced Radar for Subsurface and Ionosphere Sounding, including the team that operated it, is responsible for this amazing discovery. The spacecraft equipped with MARSIS is the 15-year-old Mars Express orbiter sent by the European Space Agency. From May 2012 to December 2015, MARSIS surveyed the region of Planum Australe on Mars, a southern ice cap of the red planet. We started looking for water in the southern ice cap of Mars after the Omega instrument aboard the Mars Express spacecraft found evidence that water ice existed at the poles. According to the ESA website, analysis of the data clearly showed that the south polar region can be divided into three separate areas. The polar cap itself was found to be a mixture of 85% highly reflective carbon dioxide ice and 15% water ice. The steep scarps, which mark the boundary between the polar cap and the surrounding plains, are made almost entirely of water ice. MARSIS used radio to reflect waves off the surface and an area penetrating the surface. The reflected radio wave data Mars Express receives can represent a signature that is representative of the materials it's made of. 29 individual radar samples were created to create a 12.5-mile wide and mile deep surface mapping where a significant change in signal aligns closely with what we see on Earth beneath the surface of Greenland and Antarctica. According to the article from ScienceMag.com, the lake was detected from orbit using ice-penetrating radar and is probably frigid and full of salts, an unlikely habitat for life. So then why is finding water on Mars important? At this point, our guiding principle in the search for life is that we should look for solar systems and planets that could contain water. We know that if we find water on Earth, we'll almost certainly find life. But more importantly, we know life, including our own, can survive there. This subsurface lake may not harbor life, but there's a good chance that it's not the only subsurface water source. So, the discovery of a subsurface water lake could now shift how we approach exploring and colonizing Mars. Let's do a quick thought experiment. You're traveling through space and you can only bring what you have with you. That means you can only have the water that you brought with you, and so that makes it a very limited and valuable resource. That will limit your mission since you can only bring that much water. So, having a planet where you can have water as a natural resource and something that the planet can sustain for you, that's something truly game-changing in the whole humans to Mars scenario. It could change the way we approach future Mars missions. Think about it. On Earth, historically, most humans gathered and lived by the water. You need to survive. That means it's very logical to think that we will set up a long-term base near a water source on the planet in the future. And survival doesn't just stop at water to drink or consume. It's also a way that we can create rocket fuel to then return back to Earth. So, to the question, why does discovering water on Mars matter? It matters because it changes the entire way we approach looking at sending humans to Mars. Having an accessible water source on location helps us have longer duration missions that are potentially safer and more successful. And we'll possibly even see a change in the short term for future Mars missions. I think it's safe to say that we'll be seeing a Mars mining mission to analyze the liquid lake for life and materials and what is there, and then plan for future outposts from there. And if they're not planning that mission, I'm just saying, this aerospace engineer wants in, so call me up, all right? But I have a feeling we'll see a change in how we approach orbiting planets of interest like Mars. Scanning the subsurface could be yet another tool for us to use when exploring the solar system and eventually the universe. So let's just say in this scenario, first, you send a flyby mission that orbits past the body in question in space and gathers scout data so you know in advance what to expect and how you can plan for a landing zone. Then, some orbiters may be included, an imaging spacecraft perhaps, and now definitely a subsurface radar scanning spacecraft. Then, you send your rovers and landers and potentially probes if it's too dangerous and hazardous. Once you do that, you can develop a habitat through sending some 3D printing rovers down to the surface, building up what you need, and then you send your equipment down to the planet ahead of time like they did in The Martian. And then we send humans to put together all of that and start the colony. What I just laid out is not a new strategy, although I did add the 3D printing rovers bit in there. But imagine doing a mission like that, where you're in the middle of a barren planet. You need critical supplies, and you need them often. That means sending humans to Mars won't happen until we set up a consistent and reliable network of supplies to the red planet. That puts human colonization a long way off because I assume it's going to take a while to develop a reliable Martian space transport. But if you can send humans to a location where there is the most valuable resource you need other than air and food, that not only makes it that you won't die from dehydration, but also helps you fuel your mission, especially a return mission. Then you've got a solution to sending humans for extended periods of time, assuming you develop the technology to convert Martian water to drinkable water and convert it into fuel, which I still believe will be achievable faster than developing a way to go from Mars as reliable to Earth as Amazon 2-day shipping. So, in short, I believe this discovery of water on Mars, which is more credible than the recent streaking that was observed that led us to look for underground water sources, is something for space history books. We have found credible evidence of liquid water on Mars. Quick! Send the mining rover ASAP, and let's get a better look. Now, it does bring up an interesting idea of what living on Mars will be like. As a friend mentioned when we were talking about the discovery, there was an interesting question of how would you feel about living underground all the time? Could you sign up for that? Because right now that's what it looks like living on Mars is going to be like. The advantage of using the Martian soil comes from its ability to protect from solar radiation that, without a proper atmosphere, would make it almost impossible to survive. But we all know that if we spent too much time inside, things start to get weird. What kind of tricks and sorcery would you have to come up with to make sure that you didn't go insane? One of my favorite sci-fi examples is from the movie Interstellar. Don't worry, I'm not going to spoil it for you, but there is a scene where one of the crew members was freaking out a little bit about the idea of just how insane it was that there's only this thin sheet of metal between them and the vacuum of space, of nothingness. The other crew member gave them a music player that had sounds from Earth, like a summer night with crickets in the background, rolling thunder, lightning. Those type of grounding techniques to simulate Earth conditions will be crucial for long-term duration spaceflight. As much as we might try to think here that we're an advanced species, we're still a bunch of apes, and we've got a lot of evolving to do. And evolution doesn't happen quickly by our standards. We'll have to develop a way to survive long-term mentally in space. All I know is there's a lot of exciting adventures and science to look forward to in the near future. And that does it for this week's episode of Today in Space. I hope you enjoyed it and learned something new. At the very least, I hope it made you think. You could find all the links to our sources if you'd like to learn more or dive deeper into the latest discovery of the water on Mars, the liquid subsurface lake. I like that. If you haven't already, please make sure to subscribe to the podcast on Apple Podcasts and YouTube. If you like what we're doing here, please give us a thumbs up and a review on iTunes. It helps us grow and it helps spread science to more people. I am your science communicator, Alex Giorfanos, and as always, I'm wishing you a great week. Make sure that you spread love and spread science. We'll see you next time.